Let's look at this concept of the frequency domain of a signal in a different way. Let's create this three-dimensional axis. A is amplitude, T is time. This is exactly how we've been looking at signals. But now actually let's look at also the third dimension here, which relates these things, but now we're measuring the frequency. So the first one, F1, we looked at was basically our first frequency, right? Which basically had this amplitude and this variations for, again, a period of 4. F2 basically is, again, A and T are the same, but what we did was we basically added and multiplied the frequency by twice to be able to have the same, twice the number of cycles in the same period. So F2 was basically a step up in the frequency domain here. And similarly, F3 was another step in the frequency domain. If you were to look at the same plot in A and T, of course, it went from here to there to this. This is how we actually looked at all of those 4 different F1, F2, F3, and F4 in the previous slides. So in essence, what we're trying to do is now look at the signal in these two axes, amplitude versus frequency, not just amplitude and time. In amplitude versus frequency, we have 3 different plots here. Of course, we want to look at it from this direction. For in the time domain, we had been looking at it in this direction, and we have seen these plots before. But now we want to be able to look at these things from that side in this axis. So one big question is, how many samples do we want in different frequency domains? Here we just showed 3. As I showed you before, if you went from n equals to 3 to n equals to 10 to n equals to 50, we were actually much closer to the final signal that we wanted. And of course, as n grew larger, we were even much closer. So of course, one big question remains is, how many samples do we want of different frequencies? Another part of it is, in the frequency domain, as we go down this axis, what each and every one of the signals contributes to the overall signal and how we can control it. And finally, the most important part why we want to do this kind of analysis in the frequency domain is, for example, here, if I'm looking at F1, I'm only looking at very coarse signal. When I'm looking at F3, I'm looking at a comparatively from F1, a more finer signal. So if we go down this axis where n is increasing, we basically, here we're going to be looking at a very coarse signal. And here we're going to be looking at a very fine signal. So if you notice, one important part of it is now we can do analysis differently for coarse signal and differently for fine signals. And that's an important part of what we want to do.